All right, so here's a practice 316 practice. This is more practice with quadratics. All right. I'm only going to do a few of them. I'll give you I'm giving you answers for a bunch of these questions. All right, so you'll see all the ones that are already done, the other ones that already have the answers there. You do them. If you have a hard time, send us an email. All right, me or one of the other teachers, send us an email. We'll help you out through it. All right, let's look at number two. Number two, here's the way I teach it. All right. So I'm going to end up, almost forgot, it's not equal to zero. I almost started off wrong. All right. So it has to be we have to force it to equal zero. So what am I going to do? I'm going to change that sign. All right. So all I'm going to do is change the sign, move it to the other side of the equal sign. So I have 12x squared minus 44x plus 35 equal to 0. Once I get it equal to 0, now I know that here's A, there's B, there's C. All right. Now, since this is going to take me a little bit of room, I'm going to slide over a little bit. All right. Now, here's the way I teach these problems. Hopefully, you guys that are not in my class are okay with doing one problem. All right. So, whatever A is, whatever A is here, all right, whatever that is, whatever that first term is, I should say, I'm writing it out twice. Then I'm going to divide by whatever A is. All right. So you'll notice there's the term for A, there's the term for A, and then there's A. All right, let's get rid of this nonsense. Of course. Oh, geez, come on, guys, cooperate here. All right. Now I know both the signs are going to be the same. All right. I look at the second sign. The second sign being positive tells me that the signs that go in here, all right, the signs that go in here are both going to be exactly the same. Well, since they're both, so, I mean, excuse me, since that that I know the signs are going to be the same because of that, they're both going to be negatives. All right. So I'm going to throw the negative in there. Now, here's where the pain in the butt part comes in. Because remember when we talked about multiplying A times C? Well, in this case, 12 times 35, all right, gives me 420. And here's where the pain in the butt part comes in. Because I have to break up 420. So I'm going to break up 420 by doing 1 times 420, 2 times 210, 3 times 140. And the reason why I'm doing this is I'm looking to get, change the color here. I'm looking to get that number. All right? I'm looking to get B. So what I have to do is I have to add or subtract these pairs. All right? These pairs there. I have to add or subtract them in order to get B. All right? And because 420 is such a big number and is divisible by a lot of numbers, this becomes a pain in the butt. All right? So either sit and watch through this or fast forward through this part. All right? There's more, but if you look right here, 14 times 30. 14 times 30 is 420. And at the same time, at the same exact time, 14 plus 30 will give me 44. It's giving me B. Well, yeah, I know it's positive, but remember we already said we took care of the signs. We already took care of the signs there. All right. We already took care of these signs. So I'm just going to throw the 14 there and the 30 there. All right? It doesn't matter which one goes where. We could have switched them. All right. Now, here's the part that I'm looking at. I'm going to look at that box individually. All right. I'm looking at that box individually. 12, 14, and 12. What can I divide all of those by? I can divide all of those by 2. All right. They're all divisible by 2. So 12x divided by that 2 gives me 6x. 14 divided by 2 gives me 7. All right, now here's where this part comes in that some students still get a little tripped up with. This 12 divided by 2 gives me 6. So I move that over. I move all that mess over here. All right, now one more time. I look at this box. What can I divide 12, 30, and 6 by? What can I divide them all by? I can divide them all by 6. All right, so I can divide all of those by 6. So I'm left with 12 divided by 6, 12x divided by 6 is 2x. 30 divided by 6 gives me 5. And then this 6 divided by that 6 gives me 1. I want to have 1 in the denominator. As soon as I get 1 in the denominator, I know I'm done with this mess here. I know I'm done doing this. Now we just solve like you did in these problems. All right. So you have 6x minus 7 is equal to 0. 2x minus 5 equals 0. Set each one of those factors equal to 0 and solve. All right. I'm not going to go through. I'm running out of room here, like always. But you solve it for x. All right. Hopefully you can do this without screwing it up. 7 over 6, 5 over 2. All right. Again, if you're having a hard time with if you had a hard time with 2 and you're not sure how to do number 1, please email one of us so that we can help you out. All right, so for these, for 3 and 4, they want us to use the quadratic formula. All right, you guys remember the quadratic formula: x is equal to negative b plus or minus the square root b squared minus 4ac all over 2a. All right, and if you look at number 3, all of this mess is equal to 0. All right, it equals 0. That's exactly what we want to have happen. We want it to equal 0. So I already gave you the answer for number 3. You guys go ahead and try it yourself after you watch me do number 4. All right. So we have to force it to equal 0 because it's not equal to 0. We got to move that negative 5 to the other side. All right. So how the hell do we get rid of it? We add 5 to both sides. So 3x squared minus 12x plus 5 is equal to 0. All right. And now a is equal to 3, b is equal to negative 12. Don't screw that up. Make sure you remember there's a negative sitting there. And then c is equal to 5. All right. So we're going to plug into our formula. Remember, anytime you plug in, anytime you substitute, always use parentheses. You guys, always it piss me off that you guys screw that up. All right. Use parentheses, please. Use parentheses. So remember, b, it's negative b. Negative b. So I'm going to throw that negative out there right away. All right. I'm throwing this negative out there right away. And b happens to be negative also. This is why you guys screw stuff up if you don't you're not using parentheses. All right, plus minus square root. Let me extend that a little further. Substitute. So you're using parentheses. B squared negative 12 squared minus 4 times a is 3, c is 5. You notice I'm using parentheses, so I'm not screwing anything up. All divided by 2 times a. All right. Now, negative and a negative, all right, those two negatives there give me a positive 12. Plus or minus the square root. Grab your calculator. Do not type in the square root button. Just do the stuff underneath. Remember what we called this, the discriminant? Just type that stuff in. Don't type the square root button in. So you're going to end up, well, I'm telling you guys not to screw up, and I'm screwing up. Come on. All right. So we have 84 over 6. All right. Now, when you grab your calculator, figure out what the square root of 84 is. It's not a perfect square. So we have 12 plus or minus the square root of 9 point, what was the square root of 84? All right. Sorry about that, guys. I forgot to write that down on my paper. All right. So it ends up being 9.165. All right. All over 6. Now, when you do this, remember you have two answers, plus or minus. You have two answers. So we're going to have x is approximately equal to 12 plus 9.165 over 6. And then we're going to have x is approximately equal to 12 minus 9.165 all over 6. So this answer here is x is approximately equal to, they wanted us to go 3 decimal places, all right? So 3.528, x is approximately equal to 0.473. All right, next ones. This next learning target is finding the vertex. Finding the vertex should not be tough, all right? Remember, for the vertex, as long as everything is on the right side of the equal sign, with the exception of y, all right? Y has to be by itself, all right? So y has to be by itself. Holy cow. All right, y has to be by itself. Now to find the vertex, we're going to do x is equal to negative b over 2a. All right, and then remember, whatever we get for x, we're going to plug that mess back into x. Okay, so let's do number 6. You go back and do number 5. I already gave you the answer. All right, so we end up with x is equal to, well, b is 2. It's positive, but we needed a negative b over 2 times a. A is negative 1. All right, everybody okay with that? All right, a is equal to negative 1. B is equal to positive 2. Doesn't matter what c is equal to. It doesn't matter. We're not going to use it. All right, so x is equal to negative 2 over negative 2. X equals 1. So there's our x coordinate. Now to figure out the y coordinate, plug all this stuff in. All right, let me erase all this mess so I can see. All right, keep in mind, there's a negative in front. What's being squared? What's being squared right here? Only the x is being squared. All right, so that negative that was sitting out here, that negative right there, all right, goes there. And then I have 1 squared plus 2 times 1 plus 8. All right, grab your calculator, do some mental math, whatever, plug that. All right, you end up with 9. So the coordinates of the vertex are 1, 9. And because let me erase so I can re-show you everything. Because this thing is negative, because a is negative, I know that this is going to be a maximum. Remember me telling you in the other video, if a is negative, this graph is going to open down, so the vertex is going to be a maximum. All right, this one over here, all right, just a quick reminder, this one over here, a is positive, this graph is going to open up. The vertex down there, it makes it a minimum. All right, so you do number 5, you do number 7, number 8. Number 8. All right. Y is by itself. Everything else is over there by itself. Okay. So we're good. We don't have to do any messing around. We can start right away. A is negative 2. So as soon as I say A is negative, I know the vertex is going to be a maximum. All right, or you can just say max because I'm lazy. I'm just going to write max. B is negative 20. C is negative 53. And again, it doesn't matter when you're doing this because x is equal to negative b over 2a. Negative. All right. Here's that negative. Those are the two negatives. When you're substituting, parentheses, don't screw that up. All right. Let me see if I can change colors here. B is negative 20. There's my negative 20. All right. Divided by 2 times negative 2. All right. Hopefully I don't have to highlight A. All right. Hopefully you guys are okay with that. I just wanted to make sure I highlighted all the stupid negatives so you guys don't mess that up. 2 negatives up here. 2 negatives give me a positive 20 over negative 4. X is equal to negative 5. All right. And then y is equal to negative 2 times negative 5 squared. Let me write it a little bit smaller because I'm going to run out of room. All right, so y is equal to negative 2 times negative 5 squared minus 20 times negative 5 minus 53. Grab your calculator. I'm not going to do all this mess. All right, ends up giving us negative 3. So the vertex is negative 5, negative 3. And again, it's a maximum because this was a negative. There was a negative sitting there. All right. 9 and 10, I gave you the answers. All right. You do them yourself. You do them yourself. All right. Let's look at number 11. Oh, come on. Cooperate here. There we go. All right. Number 11. Identify the vertex and the zeros. All right. Remember, the zeros are the x-intercepts or the roots. All right. And just remember, when they say zeros, x-intercepts, it's all that means is where is y equal to 0? That's all it's asking. Okay? Is where is y equal to 0? When they ask that, y equals 0. So they gave us this table here. They don't give us an equation. We have to state whether the vertex is a max or a min. Then use the table to sketch the graph of this function. All right, vertex. Let's start with the vertex. Well, it might actually be easier to start plotting these points so that I can show you exactly where the vertex is in relationship with the table. All right. So 0, 5, 0, 5, right there. 1, 0, 2, down to negative 3. 3. So remember, you're starting at the x-axis. You move left or right first. 3 to the right, 4 down. Then 4 down to negative 3. 5, 0, 6, 5. All right. Now, if you look at this graph, remember, a vertex is a maximum or a minimum. Well, where do you see a max or a min? Right there. There's that max or that min. It's right there. Well, in this case, it's a minimum. All right. So I can answer this question right away. The vertex is a minimum because this graph opens up. You guys know I suck at doing this, but here, let's draw a line. Well, not too bad. I'm kind of proud of myself there. All right. Now, going back to the table. Let's say they just gave you the table. They didn't ask you to graph it. They just gave you a table. Well, what are you noticing? Well, here's the thing that I notice. As I look at the y values, all right, I see 5, 0, negative 3, negative 4. The numbers are getting smaller, smaller, smaller. And then what happens is they start to get bigger again. All right. So right here, that has to be my vertex. And then if you also notice, let me erase a lot of this mess. All right. If you also notice with our vertex, look at the numbers to the left and to the right. Look at the y values. They're exactly the same. Now, is that always going to be the case? No, but on these easy ones, it's easy to spot out. All right, change the color. Look, two spaces to the left, two spaces to the right. The y values are exactly the same. What other magic little color can I come up with? All right, let's use that one. Three spaces to the left, three spaces to the right. You notice they're exactly the same. All right. So when you're given a table and they ask you to do this, look for patterns. All right. That's the thing I noticed here was, oh, this and this one were exactly the same. So instantly I'm saying, all right, there is my vertex. All right. So my vertex is 3, -4. My zeros. Remember I told you the zeros are when y is equal to 0. Well, where is y equals 0? There and there. All right, no biggie. So what's the first one? 1, 0. The next one, 5. Oh crap. 5, 0. And we already said this was the vertex was a minimum because it opened up. All right. Any questions? Please send us.